Welcome back, everybody. We're having a fabulous day. Well, before me here, I have a number of motors. Behind me on my Lapidary machines, I have a number of motors. This is a simplified guide that I can reference in the future in other videos about electrical motors, AC induction motors. And this is that. This is the simplified motor guide for the Lapidarist. If you're not into the world of electrical engineering and motors, but you have Lapidary machines and you have questions, either you're building a machine or you want to refab a machine, you have a broken motor, you're looking for answers about these things, I probably have them for you here in this video and I can reference it in the future. Little caveat, different countries have different electrical systems. I'm not talking about that. This only applies to America, okay? If you don't live in America, hey, this maybe is not the video for you. Yeah, so the TLDR of this whole thing is the basics of it. If you have a machine that you're trying to replace a motor on or a broken motor, and it's one of these types where it's a motor that is disconnected from the machine, meaning it's not like a Cab King Genie style machine where it's like the central housing, but a separate motor like this. You want something that is 1725 to 1800 RPM. That's a range, 1725, 1750, 1800. You want single phase, and you want to match up the frame and put the pulleys on it, and that's the basics of it. Now, if you want a more in-depth kind of guide to it, stay tuned. We're deep diving into the world of motors today. Maybe you can't tell, but I own a ton of motors. Okay, this homemade arbor here has a sealed Dayton agriculture motor. We have an open Dayton motor here. I forget what's in this thing. Back here we have a Leeson motor. I got a Marathon motor. I got a Westinghouse motor. There's a Leeson motor in that thing down there. Here we have the El Cheapo Garbage Tier Vivor. Here we have an old Sears Craftsman. Here we have a Marathon. Here we have a Dayton gear motor. I have a synchronous motor. And we're going to be getting into all of this, all of these topics. Now count saws, different power tools. Sorry about the mess, but you know, I have a table saw. I got routers. I got chop saws. I got all these things. There's like 30 motors out here, okay? Since you live in America, you have AC power in your wall. You get like 115 volt AC power coming into your electrical outlet. Motors come in a lot of flavors. We got induction, DC, shade pole, universal, gear motors, synchronous motors, all these different things. A lot of that doesn't apply. It doesn't apply. You don't have to worry about it. It's well beyond the scope of this video. So we are focused on single phase AC motors because it is simple in that you can have a wire coming out of the motor and you can plug this guy in to an electrical outlet and well, it turns those electrical magical pixies coming in the wires from a electrical current into a magnetic field, and it gets these guys spinning, right? And you have a field and it goes like bloop, 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 and the magnets in here translate that motion into a mechanical spinning motion, and that's the basics of how a motor works. And I'm sure somebody's going to say I'm wrong, and that's okay. We don't really need to care a whole lot about that. So, there's primarily two speeds of motor that you're going to be concerned with when looking to maybe replace a motor, and that is the 1725, 1750, 1800 RPM motors and the 3450 RPM motors. Now the high speed, the 3450 RPM motors, I have one right here. You can kind of avoid, broadly speaking, almost every single motor that you're going to use in the world of Lapidary is going to be this 1750. For lack of ease, I'm going to be saying 1750 quite often. So unless you have a special case like Richardson's high-speed standard, you're going to avoid picking up one of these. The other kind of motor that you might run into is a little motor like this. This is a Dayton gear motor. It turns at 7 RPM, and this came off of a Lapidary saw vise carriage assembly where it drives the vise forward at a very slow rate. So we kind of have these being our primary two motors that you're going to be engaging the world with. If you are unfortunate enough to have purchased a machine with a DC motor, that is direct current, not the power that you have in the wall, well, things get more complicated. There's a number of things about these that make them very nice, especially living in America. They're just very abundant, they're very simple, they're end user serviceable, and you can get some sweet deals on them. And we're going to talk about some sweet deals because I'm going to teach you how to buy these motors on the cheap. This is a good example of a motor label, and this is the important part that you're going to need to know. You're going to need to know how to read this. Every single motor is a little different, and we're going to talk about how these things kind of get wired up, but in this scenario here, we have my El Cheapo garbage tier VVOR motor, and we'll talk a little bit about the quality levels later, but our important part is horsepower, HP1. Now, there's a bunch of different horsepowers, like 1/3, 1/2, 3/4, 1. Phase, the pH, you have single phase power in your wall here in America. 60 hertz, that's the frequency of the power in your wall, and that is related to the speed that this thing can run at. RPM, this one's 1725, and we might check a motor later for that. And then the frame, and the frame is the frame FR frame. 56C. Now the C, the letter here doesn't matter. What matters is the number, and in this case, the 56. That relates to what this can get mounted to. There's a little mounting plate down below here. That's important when you're trying to replace a motor and you need to match up, let's say, a 56 frame, a 48 frame. You're going to have to know that. The CW and CW, that is for counterclockwise or clockwise, so this thing can rotate either direction depending on how you wire it up. Our volts, we can do 115, 230, obviously we're 115 being here in America. Our duty cycle is continuous. What else is important here? I believe that's kind of the important part. Thermally protected, sure. Basically every motor has the max ambient temperature of 40 C. I don't know why they use C, that's like 100 degrees or whatever. 100 and some change. Yeah, that's about it. So depending on what your use case is, well, you're going to basically be looking for horsepower, phase, and frame and RPM. Those are really kind of the big ones that you're going to be looking for. By comparison, you can see here on this one, we have this 3/4 horsepower, and it's an E56 frame. But the important part is the RPM, which is 3,450, and that is not what we want for many scenarios here. When you're selecting a motor for lapidary use in an environment like this, where we work with water and the motors are generally well separated and put away from the actual, wet part of the machine, you're going to want something that's air-cooled. Now, that machine back there has a green Dayton agricultural motor on it, and it is entirely sealed. This isn't actually ideal. You want something with a fan. Here's an example of a motor with a fan, and this is about what they sound like. Now, we have a fan back here in this housing. See that thing spinning? I know it's rather difficult to tell, but so the 1750 over here, and we'll turn this 3,450 RPM motor on. Significantly faster. a lot of lapidary wheels, blades, things like that have a max RPM rating of 1800, and that's why you can't take a lapidary saw blade as an example and put it on a tile saw. It is spinning way too fast because a lot of tile saws have a motor such as this in it. When I was talking about the frame, I'm talking about this. Okay, this is a frame that is permanently affixed to the body of the motor. This one's like a little cradle type, and this one is also attached. But you can see we have different styles. But what matters the most is this distance right here, because that's where you're going to have bolts that hold this thing down. And you can see the distance between that hole and that, the end of the shaft, is the same on all of them, even though we have 3 very different sizes of motors. The other thing you might notice here is this motor has this kind of bulbous thing right here. This one also has one right here, and this one has 2 of these. Underneath these covers are capacitors. Now, a capacitor, kind of like a battery, but it can like dump all of the power all at once. These have start capacitors. This has a start and a run capacitor in here. Now, if I was to, let's say, disconnect the capacitor from this, I would plug it in, turn it on, and you would hear a buzzing sound. It would just be like, me, and no movement. Now, it's entirely possible that you could come over here and kickstart the shaft, right, or whatever is attached to that shaft, and it would get spun up. The capacitors do eventually go bad on virtually all motors, given enough time. So these have that to help turn over that shaft in there with the magnets and get the magnets like turning based upon that polarity shift between the fields, magnetic fields. Now, in the 3-phase world, it's more of a turning field, and you don't have to have the capacitors all the time. This one has a capacitor here and a capacitor here. The one that keeps the thing continuously spun up, and it's a slightly better design. So you already heard me refer to this VVOR motor as a garbage tier motor. Virtually every single lapidary machine manufacturer now that ships out motors will be sending you a garbage tier motor. Now, like I said, I have Dayton's and Leeson motors, old Made in America motors. I got a lot of things, okay? The reason I say this is because there's like 1 or 2 factories in China that make a ton of motors, all basically with the same housings. They put their own different little stickers on it. It could be Waylead, Smith & Jones, VVOR. They're all like coming out of the same place. And you get lower quality bearings, lower quality capacitors, lower quality windings, and more cheapness, for lack of a better term. Like it could be the hardware on it wants to strip out. When you open these things up, there's just a lot of factors where they cheap out on them. You can see here, this one's got a ground smooth face. This one does not. This one can be face mounted to a thing, like bolted to it. Sometimes these aren't ground actually flat. There's a bunch of different factors. You kind of get what you pay for. But as an example, this VVOR motor I paid $115 for, which that's definitely on the low end. And here's what a higher end 1 horsepower motor looks like price-wise. So a significant difference, and depending on your application, it may or may not matter. I'm going to be running this and giving it a go and see, and maybe I'll report back at some point in the future. But basically, you get what you pay for. So, I have, like as an example, this Sears Craftsman motor does it even say the year on it that it was made? It does not. But it does say on it, general applications and jointer, wood shaper, and belt sander, and disc sander. So, back when Sears was quality. But Sears still exist? I don't know. Well, that kind of covers some of the big differences that you're going to see and run into with these motors. So, just to recap real quick, you probably want a 1/3 to 1 horsepower AC motor, single phase, 1750 RPM, and 48 frame for the little guys, 56 frame for these bigger guys. You're gonna bolt that thing on. We're gonna talk about wiring these guys up next, and you should be good to go in many cases. Every single motor is going to have a little wiring diagram on it, just like this guy here. So I can't exactly tell you how to wire up every single motor that exists since they're all a little different, but you can see that this one means combining a bunch of wires using wire nuts. This older one here means using little blade terminals. And this one also is a little blade terminal. You can see the blue terminal there and connected to ground. And this is the wire that goes to the wall. But that's kind of the basics of all of it. Everything's going to have a little diagram, and you're going to have to follow that diagram to wire it up. This here is a little 7 RPM gear motor. It's a Dayton, quite old. Actually, I have a replacement coming. But for demonstration purposes, I thought we would wire it up real quick. So, got the hot and neutral. Don't need ground. Ground is overrated. Who needs a ground? I don't need a ground. And it might take a little bit. All right, so motors like this are pretty torquey, very slow, and that is the intention of them. Okay, you can see how chewed up that little shaft is there that you'd put your pulley on. This guy is junk. Junk. But it is a good representation of a type of motor used in the world of lapidary. And how you replace these is pretty simple. This here just so happens to be the working sheet to, well, I guess, see some precise measurements of this motor. The measurements we're concerned with are the bolt pattern, because this is going to get bolted to a saw. So that's all we really need to know, and we can match up our RPM, and you're pretty good. That's the basics of the gear motor. That's the basics, at least. This guy here is a great example of a motor that you might be wanting. I bought this on Facebook Marketplace. The person said they bought it and never hooked it up. And I have a couple of clues as to the truth or lack thereof behind it. Obviously, our housing is not screwed up at all. The sticker is intact. Do you see this right here? That is residual tape, and that held on this. This is the shaft key for putting a pulley on, and this was taped right here. And you see that jagged line at the bottom of that? That is masking tape coming off of a more, I guess, commercial tape dispenser. So that is a very good sign, very good sign. This motor, if we were to take it apart, we have this bell here, which that's the silver part, and this bell here, and you can take these off and pull the shaft with the magnets, and you can look inside and you basically see a coil. Pretty simple. I'm going to take one of these covers off so that you can see what a capacitor looks like. So there's a couple of reasons why you might want to save a motor. If the motor is just humming, you can buy new capacitors. Capacitors look like this thing here. Yep, look like that thing there. And you can discharge them, and you can look that thing up, and you can just buy yourself a new capacitor. Pretty easy. Just look up whatever the codes are on that thing and go find yourself a new capacitor on the internet. So you see something on Facebook Marketplace, it looks good, everything sounds great. Maybe there's a wire connected to it just like we have here, and you're able to go to their house and plug it in, and you're like, oh, that seems pretty good and just about right. Wrong. There is a range here of things where you can be like, hey, it's $30, and like you just don't care, knowing that you could easily get new bearings and you could put new capacitors on it, and it's a screaming deal. Just go scoop up that motor. If it's a little bit higher priced, well, you're going to want to check a couple of things. So assuming it has a cord on it, this is extra easy. You're gonna bring some tape with you. You're gonna flap that on there. You're gonna buy yourself a tachometer, just like this. These are quite cheap on Amazon. I'll throw a link down there, and it comes with some reflective tape. There we go. Peeling stickers off of tape, or peeling the back off stickers, is not my not my thing. So we're gonna check and see if this thing is actually running at either the 1725 or the 1425, depending on how it was wired up. So we would plug this guy in, and all you gotta do is hit this button, okay, and it aims a little light, and we're gonna aim it at this reflective thing, and we're gonna check it. So, yeah, can you see that? I don't want to get we're like 1800 RPM. That's great. We're close enough. This is good. It's running nice and smooth, and we are very good. Other things that you might want to check, you should be able to go and free spin this. It should feel firm, but should be able to turn both ways. No horrible grinding sounds or anything like that. So once you've determined that, you're pretty good to go and buy it. However, maybe it doesn't have a wire on it. That means you're gambling, or you should put together a little kit that you can bring with you when you go motor shopping. You're gonna need some things: your digital tachometer, box cutter, wire stripper. Doesn't have to be a nice one, go to Harbor Freight. You're gonna need a universal 3-prong plug like this. You're gonna need some bits and bobs to put together your kit. You're gonna take with you 3 wire nuts, 3 of these butt crimps, these blue guys here. You're gonna take, these are the little blade style ones, and those are 12 gauge, I believe. These are 16-14 butt crimps and some ring terminals, and you're gonna put all these things, these little guys, in a Ziploc bag, and that'll be part of your kit. You need a piece of wire, some 12 gauge 3-strand wire, and you're gonna put this plug on it. So if you've never done this before, super basic, right? You're going to open this up. This wire here comes on by the foot at Home Depot. Now you got your 3 wires here. You're gonna strip a little piece off of them. This is 12 gauge. Grab this here just like that. Don't need much. People often strip off too much wire. Just need a little bit to stick in here and make our connection. That one didn't really want to go. Okay, just like that. We got our 3 stripped wires. We have a silver, brass, and green, black to brass, white to silver, and green to ground. Should look something like that. Kind of line that up. We close it. All right, now we have, well, our little test cords here. We're gonna strip a longer amount off of this. So now we got this, we got our little parts here, and we can bring this with us when we go motor shopping along with our tech, and ensure that you are not getting completely hosed by somebody. Now, just like a real electrician, you take all these little bits and you throw them on your floor and forget about them. They're for the next person. Also, don't forget this thing. So you got your kit, you got your tools here, you're ready to start motor shopping. Time to find a motor is not when you need a motor. The time to find a motor is when you don't really need it, right? You definitely waste time on the internet. I waste time on the internet. Go load up Craigslist, Facebook Marketplace, Kijiji, whatever the used marketplace, internet ads, eBay, and start searching for motors in your free time. That's when you find the good deals, is when you don't actually need it. And the same thing goes with these pulleys that go on these. The time to find good deals on pulleys is not when you need a motor or a pulley. You got to get ahead of it. Well, the other topic, last topic that we're going to talk about is controlling the speed of these. That is inevitable that comes up in conversation. The big downside with DC motors is they whine, they get hot. Even the ones that are continuous duty that wasn't a good way of saying that. Even the ones that are continuous duty, they get complex. They have weird bolt patterns for mounting. They have little controller boxes. When it comes to AC motors, single phase, like you have in your wall here in America, the speed of this is regulated based upon the line voltage, like 60 hertz, 50 hertz, right? Like that is that's what the speed comes from. And when you get something like a little knob voltage regulator, potentiometer thing from like Harbor Freight or whatever, which lowers the voltage, you are permanently damaging this motor. You're permanently damaging it. You can't control this. You control the speed of motors like these with different size pulleys. I will put down below a link to a website that has a pulley calculator. If you can't do the formula yourself, you can just go put your numbers in, like the motor speed and different pulley sizes, and it will do all the calculation for you and give you a nice graphical representation on how to do this. If you do really want to change the speed of a motor, you buy a 3-phase motor and that 220 volt 3-phase motor. You buy a VFD, which is a variable frequency drive. You can take single phase line power out of your wall into the VFD, into the motor, and then you can perfectly control it while maintaining high amounts of torque. Another downside to DC motors on lapidary machines, like let's say a cab machine, is as you press, that thing bogs down and you're slowing it down. And that contributes to the shorter lifespan of that brushless DC motor. The reason manufacturers are going this route and putting El Cheapo garbage motors, either be AC or DC, it is money. Loretone was the last lapidary company that has sent out machines with quality motors, primarily Leeson motors. My 20-inch Oslap actually has a Made in America Leeson motor on it, and yeah, now everybody's sending them out with these types of motors. In my opinion, all manufacturers, be it Highland Park, Covington, whoever, should give you an option of buying with no motor, buying with a garbage motor, and buying with a premium motor, and explain the differences between those things on their website. That's not going to happen. I would be shocked if it did. When it comes to shopping for motors, brands that you're going to want to look for, Dayton, Leeson, Baldor, Marathon, who am I thinking of? Any of these big brands, maybe in a future video, if anybody's interested, we might save a broken motor where we do a full disassembly of it, new capacitors, new bearings. There are a couple of reasons to save a motor. As a prime example here, Graves used to sell a single-wheeled machine called a cab mate, and they would actually disassemble the motor and paint it to match. So maybe you want to save that housing. Maybe the coils are still good. A couple of other things, last couple of tips I'll leave you with. If a motor smells funny, if it is sparking, if it is not free to turn anymore, or it's like grindy, you have bad bearings, you have a melting coil, bad capacitors. Prime examples of this, I think just about every lapidary manufacturer in existence now, Covington's no exception, have sent out machines with low garbage tier motors, and they've experienced issues. I've heard about them firsthand. So if you don't want to do the internet shopping, like this thing, I got this thing off Amazon, super deep discount deal. Surplus Center is another website that I've purchased from in the past. You can go shop Surplus Center. Well, throw your motor questions down below, and I will be referencing this video in the future. For everybody else, go check out the website, go check out Patreon, give me a subscribe, give me a like if you found this to be informative. Throw your motor questions down below, and I'll catch you in the next video.